Hi, Desmos team. This is Katie O'Brien. I am here to finish up my application for the fellowship, and I am going to show you one of my favorite things about Desmos, which is the ability to graph in polar coordinates and then also to make GIFs or GIFs, depending on who you are and how you pronounce it. So I'm going to start by screen sharing here, and let's go to this guy. All right, so right now we should be taking a look at what eventually we're going to make, which is this, this graph that connects the equations in a Cartesian plane and then in a polar plane to see how they're connected and how we get these cool looking graphs. So I'm going to go to Desmos and we're going to start graphing. One of the reasons why I like using Desmos for polar coordinates is because it's hands down the best tool. Using a traditional Texas Instruments calculator just does not cut it, especially when you look at it compared to Desmos. So I'm going to start by just putting in a equation for a general sine function. So sine of, let's do bx, and we're going to do plus c here. And if you notice right away, it asks if I want to create sliders because I didn't put numbers into this equation. So I'm going to say, yep, I do want to, and they pop them up right away, which is fantastic. And I think the sliders in Desmos kind of give students a way to play around with things that make it a little bit more tactile than a traditional calculator does. And then I'm also going to go ahead and I'm going to give it the exact same equation, but using the polar coordinate. So y equals sine of, gotta find my theta here, theta b theta plus c. All right, so you can already see I have kind of a little funky graph here that popped up from the polar coordinates. I love polar coordinates because they're so visual, and like I feel like they're meant, especially these types of graphs are meant to be seen and visualized, and the old calculator just did not do that. So specifically, I remember when I was taught about polar coordinates, it was kind of like if the equation looks like this, then you have a cardioid, otherwise you have a rose, and then if it looks like this, then you have a rose with double petals. And so it didn't really make sense to me until I started to make the connections between the equation as I thought about it on a Cartesian plane and the equation as I thought about it on the polar coordinate system. So I'm going to do that by making some restrictions in here to show what my graph looks like and how it's related to the traditional graph.